and welcome to Pale Blue Pod, the astronomy podcast for people who are overwhelmed by the universe but still want to be its friend. I'm your host. I'm Dr. Moiya McTier. I'm an astrophysicist, a folklorist, and a good friend to the universe. And I'm recording from my office here at Pale Blue Podiversity, and I'm expecting a guest. Moiya DeCotis is a comedian, actress, and writer based in New York City, and I believe I heard her passenger elephant trumpeting outside a few minutes ago, so she should be here any second. Moiya, come on in.
Hi, thank you for having me.
Of course. How are you doing? How was your ride?
It was great. You know, I'm so small that elephants are so big that I was luxurious. I had so much leg space.
Right, you're just rolling around on the back.
It was awesome.
Nice, nice. Are the ears soft? I feel like they look soft, but they probably aren't.
No, they're so soft. The rumors aren't true. Yeah. This is a common misconception about elephant ears. They're actually like big, soft blankets.
Yes. Oh, I love that. Well, I will probably ride out with you on the passenger elephant later. Is there anything else you would want people to know about you before we get started?
I don't think so.
Okay, great. Awesome. Well, I do have some get to know you questions, so I can guide it a little bit. I have 5 questions for you. The first is the heaviest, I think, and it's when you think about space and how big the universe is, how do you feel?
Yeah, I mean, I think probably a lot of people say they feel small. It does make me feel really like small and insignificant, but it also makes me feel in awe. Like I'm just in awe of how crazy big the universe is. It's inspiring. Mm-hmm.
Inspiring. Nice. It doesn't fill you with any sort of anxiety or anything?
I wouldn't say anxiety because there's nothing I can really do about it.
Love.
I feel like I only get anxiety about things that like actually matter. Do you know what I mean?
Yeah.
It's like what's going to happen? I mean, we're all just existing. I don't know.
Right. Space is there no matter what.
Yeah, I can't really do anything about it. So
awesome. Do you have an example of how it's inspired you?
There's so much about space that's like unknown and mysterious, and like people are yearning so much to know so much about it and study it and like pore over the details of like what's happening in our universe. And I find that inspiring, that it's just doing its thing and it's amazing and it doesn't have to like try to show everyone how amazing it is, because it just is, and people are absorbed with it and obsessed with it. And for me, that's like a good like reminder of creating your own universe and not trying to be always accepted by other people, or, you know, if you're in an industry, like, oh, I have to be accepted by this person, or I'm not successful, or I have to have permission to do this. And I think the universe is a good reminder that you don't have to have permission to do anything and you can create your own orbit.
I'm obsessed with that answer. Yes. Yes, I love that. Thank you so much. It's rare that I hear someone's perspective on space that's like expansive on my own, and that was really nice.
I'm glad.
Yay. Okay, next question. Do you feel like your astrology sign, your sun sign, fits who you are as a person?
Oh, yeah, like 100%. Yeah.
What is it, and like how do you identify with it?
Well, I'm a Scorpio, so I feel like everyone is like always talking about how evil Scorpios are. I don't feel evil. I really don't. But that's an unevolved Scorpio, I think, because I don't feel evil. I feel like Scorpios are also known for being deeply passionate, and like there is also some air of mystery there. And, you know, I'm a comedian, so I am really into mystery because I find humor very mysterious and like elusive. So that's like a big part of like what surrounds my brain every day. So I definitely do feel like that's probably a part of it. But yeah, the passion, the intensity, we're very intense. I feel like I'm a very intense person, and I like that about myself. I don't want to be casual and chill about, you know, whatever. Life is intense and it matters, and I care a lot about people. And so I think I identify with those Scorpio traits for sure.
Oh, nice. You're chalant.
I'm the most chalant.
Amazing. As a Capricorn, many people think that I am also evil sometimes. So I get it. I get it. You don't seem evil at all.
Thank you.
A very evolved Scorpio.
My other 2 signs are Capricorn. What is it? Rising and moon?
Mm-hmm.
Yeah.
Okay, what do you think is the worst planet?
The worst?
Yeah.
Oh my God, can I say Earth?
Yes. Yes. Dude, same.
Earth has so many problems. Oh my God, it has so many problems. I mean, I don't know enough about the other planets, but I know the most about Earth, I think. So I would say Earth.
Would you be able to pick out a best planet of the other ones?
A best. Saturn is cool. I don't know if this makes it the best, but I think it's just cool. I think it looks cool. I think it has style and yeah, like aesthetically very pleasing. And it's, yeah, I don't know enough about planets, but it's made of gas, right? Yeah.
Yes.
So I think that's also like, it's definitely doing its own thing. It's like, I'm not like other planets.
I'm special.
Yeah. So I think that's cool.
Nice. Yeah, it is a pretty color. And the rings are nice.
Yeah. I mean, can anyone even land on Saturn? No. See, isn't that so cool? That's the best planet. That's the best planet. No one can even touch me.
Yeah, I agree. Saturn's gorgeous, but as I discussed on last week's episode, if you really like Saturn, you should go out and look at its rings now, because starting in November, the rings are going to not be visible for like many months.
Really? Why?
Yeah, because the planet is like spinning so that its rings, we're like seeing them straight from the side, and they're so thin that they look invisible when they're not. We call it face on, like when we're looking at them from above, but now they're edge on.
Wow.
So we can't see them.
So it's all about perspective.
Always. Yeah. Studying space is purely about like perspective and reference frames and trying to tease out information about that third dimension, because everything looks two-dimensional to us. That's how we get creative.
Elusive.
Okay. Next, what law of nature would you change if you could?
I would make karma just like a law of the universe.
Yes. Adding a law. Oh, I love it.
This is very Scorpio. But I just feel like that should be a thing fully. Like, you know, we know that, you know, every action has an opposite and equal reaction, but I just feel like we could go a little further. It could be a little stronger, and that the actions could have similar qualities. Like the reaction will have a quality of the action that enacts karma. That's
yes.
what I want.
You know what? I'm writing to the universe right now and be like, we got to get this going, please. I once saw such beautiful instant karma that like my faith in the universe was restored a little bit. It happened last year and I still remember it. But I was looking out my window and I saw a man pee on a truck that was not his. And I know it wasn't his because he then got in the car in front of the truck. And then he had to get out for something to like throw something in the trash. And he stepped in dog poop on his way back to his car.
It was immediate. Immediate would be great as well. So I want it there. Immediate, even better.
Yes, immediate and in kind, please. All right, yeah.
It's so satisfying.
Note out to the universe immediately. Awesome. And final question. I think this is the least fair question I ask, actually. If you were an astronaut and you're about to blast off into space, but you're in charge of the playlist while you do it, what song are you playing for launch?
Well, I was thinking about, it would be nice to have some kind of classical music, because I think that would like really set the scene of like you're being blasted into space and like how insane and amazing it is. There's this album of a cover of Bach's Sonata No. 1 by Chris Thiele, and he plays mandolin. He does the whole thing just on one mandolin.
Oh.
It's beautiful. It's like, it's insane. And I love the mandolin. Like, I just feel really connected to the mandolin, like culturally. So I like love the sound of it and the feeling of it. And that just like mixed with Bach is like a really mind-blowing experience. So definitely that, or Chapel Roan. Or some like hot pop.
The extremes. I love it. Do you play the mandolin or any other string instruments?
I don't play the mandolin. I play the ukulele, but I'm not like doing it all the time. I can play.
Okay. Yeah. Okay. Yeah. Well, we'll also send your ukulele with you to space because we don't want you to get bored.
I can imagine there will be a lot of downtime.
Actually, not really. I mean,
No?
astronauts' days are pretty planned out. They have to
Okay.
exercise a bunch so that their muscles don't atrophy. They have science experiments that they're doing up there. But, you can decide the nature of your trip. The university does like to let people choose their space exchange program activities.
You have to have a hobby.
I feel like I know you so much better now. Thank you for that.
Yeah, thank you.
Awesome. Are you ready to hear about some collisions in space?
I'm so ready.
Before this, have you thought much about collisions in space and how often they happen?
I've thought a little bit about it. I don't know how often they happen, but it seems like they're happening all the time.
Yes. Well, I think you have a better understanding of space than a lot of people, actually. Most that I talk to feel like space is pretty static and not moving or interacting with things. So yes, you're on the right track. Collisions happening all the time. In this episode, I really want to talk about collisions on a bunch of different scales. So starting with the very smallest collisions that can happen all the way up to the biggest collisions. Or I could go big to small. Which would you prefer?
Let's start small.
Small. Okay, great. So photons, these are fundamental particles. I'm starting with the smallest things we can. These are particles of light. And light is both a particle and a wave, so photons are weird. And one of the weird things that happens is when photons themselves collide, which is really rare because photons are so small and the universe is so big. But we do know that there are a lot of them. There was a paper a couple years ago that looked at quasars and blazars. Have you heard of these?
I've heard of quasars, not blazars.
Yeah. So quasars and blazars are both just really energetic black holes, and they're so energetic that they shoot off these beams of light. And for a blazar, that beam of light is pointing towards us, so it just looks brighter. But blazars and quasars are they're the same thing.
Okay, so the difference is the perspective?
Exactly.
Okay, got it.
This is going to come back a lot, Maria. Don't you worry.
I bet.
So they were using blazars and quasars because they're really bright objects, and you can study how that light interacts with things around it, the gas, the dust, all of the other types of light in the universe between the quasar and us. And what we've been able to count so far is that there are I don't even know what the number is for this, but it's 4 and then 48 zeros.
Okay. Yeah, not sure what that would be called, but
Neither do I. But it's a really big number, and it is still only a tiny fraction of the universe. Something like 0.001% of the universe is these photons, and there's so many of them. But when you have the rare occasion of 2 really high energy photons, so we're talking like gamma ray photons, if you're familiar with the different types of light.
I'm familiar, but don't know everything.
Yeah, so some photons are much more energetic than others. The least energetic are the super long wavelength radio photons. And they're just like slowly swimming through space. And then you have the really high energy gamma ray photons, and they are zipping through space. Think of like the radio photons, they're like big whales. And then the gamma ray photons are like tiny little minnows.
Got it.
Yes. So when 2 minnows happen to hit each other in space, a really fun thing happens. They collide and they create like a short-lived particle that then decays. It breaks apart. And the result is 1 electron and 1 positron. And a positron is antimatter. It is the antimatter counterpart to the electron. And so we've been able to observe this a couple of times, and we've even been able to create it in labs, but it takes really high power lasers to do it. But we've been able to create antimatter by smashing particles of light together. And this is called the Bright-Wheeler process that we can make happen.
But you can observe this in space. You can see it happening in space too.
Yeah, you can see it around those blazars and quasars because those jets are, really high energy gamma ray streams. And especially if you have like 2 jets that collide, you can see what happens in that space, and we can detect that there are both electrons and positrons.
So you can see it happening in this specific place because of the black holes.
Because, well, at this point, I think the light is away from the black hole. We're not looking at the black hole itself, but the area around it. But yeah.
So they have to be near it for you to see it?
It's that you're seeing how the light passes through the gas around the black hole. And there's always gas and dust swirling around black holes because things are attracted to them.
Okay, interesting. Wow. That's so cool.
Yeah, I know. Did you know antimatter was real?
No, I didn't know that was a thing.
Yeah, it's real. We've observed it, and we can even make really, really tiny amounts of it.
I can't even really grasp what that means, antimatter, like something that is not existing.
Or it exists, but it's like there are positive numbers and negative numbers, and the negative numbers doesn't mean it doesn't exist. It's just like the opposite concept, the antithesis.
Wow.
And one of the coolest things about antimatter is that we only exist because in the very early universe, for some reason that we don't understand, there was ever so slightly more matter than antimatter. Because when you get them together, they annihilate each other. They cancel each other out.
Oh my gosh. Wow. Okay. Wow.
Mm-hmm.
Violent.
Extremely. Yeah. Yes. So there is antimatter, but when it comes into contact with regular matter, they destroy each other. So it's hard to produce.
Wow. Incredible.
Science.
Yeah.
Would you like to hear about the science of nuclear fusion?
I would love to hear.
Great. Yeah, this is the next step up. So if a photon is a fundamental particle that cannot be broken into smaller parts, the next thing we're going to talk about colliding is the nuclei of atoms. And nuclei have both protons and neutrons in them. But protons and neutrons are both made of even more tiny particles called quarks. So a nucleus is not a fundamental thing.
Okay.
So nuclear fusion happens in stars, also here on Earth, but I care about the ones in stars more. And it's driven by the strong nuclear force. Have you heard of this?
I have not.
Great. There are, as far as we can tell, 4 forces that kind of dictate everything in the universe. There's gravity, electromagnetism, which is light, and magnetism. And then there's the weak and strong nuclear forces, which operate on nuclear scales of like things involving a nucleus. And the strong nuclear force is the strongest of all of the forces. It overcomes electromagnetism, which is what keeps like charges apart. So normally protons, which are positively charged, you can't get them close together because they would repel. But if you get them close enough, closer than the width of an iron atom, then the strong nuclear force can take over.
And so then they collide.
And then they, with almost like a shepherd's hook, they reach out and they hook onto each other and they pull each other in. And scientifically, the way they do this is by exchanging a very tiny particle called a meson back and forth. And as long as they're close enough to exchange this type of particle, they can stick together.
So it's a symbiotic relationship.
Yes, between these particles. And neutrons, because they don't have any charge, they don't experience the repulsion from electromagnetism, but they can still exchange mesons. So within a nucleus, the reason it's so strong is because the strong nuclear force is holding it together by making them play ping pong back and forth with the mesons.
Okay. And so there are strong nuclei, and then there are weak ones?
Yes. Yeah. I haven't thought about it that way, but yeah, the weak nuclear force is responsible for the decay of atoms, making it dissolve into other pairs. So yeah, I guess that is about the weakness of the nuclei.
Interesting.
So in the stars, where fusion happens deep in the core, you need high temperatures and pressures. You need temperatures to be millions of degrees, and you need pressures that can pack the particles in closer than the width of an iron atom. This is also why stars cannot fuse elements that are heavier than iron, because the strong nuclear force doesn't work anymore. On that scale. Yeah. So you need super hot, super densely packed regions. And once you get that, you smush the nuclei of hydrogen atoms together. And because you're taking two hydrogen atoms, you combine them, and the thing that results, a helium atom, is less massive than the sum of the two hydrogens. That missing mass has to go somewhere, and it creates energy. This is one of the real demonstrations of Einstein's mass energy equivalence, the E equals mc squared thing.
Okay.
Yeah, so we can calculate what mass goes missing and then measure the energy that is produced. Mm-hmm. But it's not as simple as one hydrogen plus one hydrogen equals one helium. It's actually a much more complicated process, and there are two ways it can happen. In stars like our sun, or stars that are lighter, less massive and cooler, we have what's called a proton-proton chain. Now, when I was in grad school, in my first or second year of grad school, taking a stellar astronomy class, it was at 8 a.m., and I am not a morning person, so I would fall asleep often, but I would wake up every time the professor talked about the proton-proton chain, because astronomers call it the PP chain, and then the students would laugh, and then I would wake up from their giggles.
So actually the humor saved you in that class.
It did. Yes, so according to the PP chain, you have two hydrogens together. Each hydrogen only has one proton, no neutrons. So you get these two hydrogens coming together, and that's why it's called the proton-proton chain, because you have two protons coming. And they make a positron, so the opposite of the electron, plus a neutrino, which is another tiny, tiny particle, and deuterium, which is a type of heavy hydrogen. We haven't even made a helium yet.
Okay.
That deuterium can combine with another single proton of hydrogen and make a gamma ray photon. This is why fusion produces light. That's the energy that gets released. And then an isotope of helium. We're still not at regular helium. That isotope of helium can combine with another isotope that is produced through another chain process. And then when they combine, they briefly make a beryllium isotope. Beryllium is a higher element on the periodic table. And then that beryllium will decay, thanks to the weak nuclear force, into a stable helium isotope.
Wow, there's so much happening there.
Yes. And so this is the stuff that astronomers' students are learning at 8 a.m. in their classes.
That's so rough.
Yeah, be kind to them before they've had their coffee.
Yes. There's so much drama in there. There's so many different relationships happening. It's literally like a reality show. It's like Love Island.
It is a new helium isotope bombshell has entered the villa.
Exactly.
I often think about writing a book that explains these small processes, and I like to personify physical phenomena in my books. And so framing it like a reality show, or all this drama and all these relationships. Yeah, I love it.
Yeah, it's what it feels like. Mm-hmm, and everyone has different energies: positive, negative, weak, strong.
Mm-hmm, mm-hmm. Sometimes when a positive and negative get together, they literally annihilate each other, cancel each other out.
Oh my gosh. Oh, it's too good.
Hey there, it's me. Maria found my perspective goggles that let you see a scenario from any reference frame as long as you set it in the right coordinate system. I quested across the realms of science and magic to find them instead of studying for my physics exams in college, but hey, it worked out. And now I have some time to share some messages with you while Maria plays with them. So first, I want to say thank you to all of my patrons who support the show financially every month. As an independent podcaster, it would be so hard to make Pale Blue Pod without your support, so thank you so much. And I want to give a huge thank you and special shout out to my sun-like stars, Scott Reynolds, Tom T, Nicole Bartlett, and Ashley Shambo. You're golden, and your mass is perfect for holding our solar system together, so thank you so much. And I would like to welcome my newest pre-main main sequence star Megan. Hi, Megan. Now that you're a member of this awesome group, you can make it onto the patron star chart. Go to palebluepod.com to check that out. You get research notes for most episodes, and you've heard your name on the show. Everyone else who isn't a patron yet can join for $5 a month at patreon.com/palebluepod. Brighter tiers, like My Son Likes Stars, get access to Pale Blue Pod at night, where I read bedtime stories in a calm, soothing voice, and there is a new PBP at night coming later this week. So thank you to all of my patrons, and if you're not one yet, and you can sign up, please do. I would appreciate you forever. My next message is from Multitude. Have you heard that we're doing the multi-crew drive? From now until September 26th, we're saying thank you to you and our multi-crew members with giveaways, bonus episodes, and community events. Making a sustainable living in independent media is hard, and your support of the multi-crew lets us here at Multitude do all the things that capitalism usually makes us stop doing: experimenting, learning, making art, and sharing our knowledge with others. And because your support sustains our business, fuels our growth, and makes our hearts warm and fuzzy, we want to give back. First, all members of the multi-crew get 6 brand new exclusive bonus podcast episodes, like my Exolore Reprise, where I discussed the world building in Sinners, the hit movie with editor Misha. You can get access to those immediately by signing up for the multi-crew today at multitudeshows.com. That link is also in the episode description. Joining at any level helps us here at Multitude work on new and exciting projects, and it gets you access to some awesome, cool rewards. Plus, if you join on an annual plan, you can get 2 months for free right now. Second, we are hosting a scavenger hunt giveaway for our entire community, where you can win cool swag by documenting how much your favorite shows impact your daily routine. Head over to Multitude Shows on Instagram to learn more about how to get in on the action. And while you're there, you can check out the community events we're running on Twitch as a big thank you. Come hang out with our hosts and the Multitude community. You know, it actually warms my heart to be a part of this group of independent creators who all care about making good art while having fun and being good people along the way. It's so easy to get lonely and overwhelmed in the indie space, and Multitude helps me avoid that. They helped me start Pale Blue Pod. They gave me the money to get the cover art and the theme music and everything. So I'm really appreciative to Multitude, and I just think more people should know about it. So be the hero we need in independent media and join the multi-crew today. Head over to multitudeshows.com to join. My last and final message is to please watch That's a Lot on Instagram, YouTube, and TikTok. Episodes 10 and 11 are out this week. We're almost at the end of the series, only 14 episodes total, so you can really watch most of the show already and catch up now. Episodes 10 and 11 are a fun little palate cleanser for the darkness that we've been putting into the show, obviously with a lot of humor lately, but check it out. That's Instagram, TikTok, YouTube, links down in the episode's description. All right, Maria got a little dizzy watching the galaxies spin from our central supermassive black hole's perspective, so we're going to give her a second to get her bearings, and then we'll get back to talking about collisions in space. But that whole process is just for stars that are like our sun or smaller. For more massive stars, they have a different process altogether called the carbon-nitrogen-oxygen cycle, or CNO cycle. And this cycle is necessary when you have higher temperatures, because high temperatures give all of those particles a lot of energy. And so you need to exceed that energy to force the particles to come together.
Okay.
Yeah, so they use carbon, nitrogen, and oxygen as chemical catalysts for different reactions where, these elements don't actually get used up, but they will incite other chemical reactions in the star that eventually produces helium molecules. And it's even more complicated than the first one, so I'm not going to go into it.
Yeah, so there's some manipulation happening.
Yes. I'm here for your
I
personification.
have to frame this around reality TV.
Please do. Yeah, I guess if the PP chain is more like Love Island, then the CNO cycle is like Survivor or something, like where people are getting voted off.
Yes, the cutthroat.
Yes. So that's fusion. Did anything about that surprise you?
I mean, all of it is surprising. I mean, all of it is so complex. And I feel like a lot of it, like you said, it's simplified. Like, you know, when we learn about these things in school, E equals MC squared and all that stuff, that it's so much more complex than that. And finding the equation was probably, I mean, then you just really think about how hard that was. Like, man, that must have been really hard to find that equation.
Yeah, and E equals MC squared isn't even the full equation. Like, that's the simplified version.
Right.
Like there's another term that deals with momentum and everything, but you usually just can cancel it out and set it to zero.
Yeah, well, I feel like it takes a certain level of when I'm hearing about this, and you talk about it with such like ease and grace because you know it so well, that it's like I'm having to try to like, yeah, get to the levels of my brain that can grasp it, you know? So it's like, it is like an expanding. Yeah, like I have to try to keep expanding.
Yes. It is a mental workout for me also to think about this stuff. Because I had to relearn all of the fusion stuff for this. So
Little refresher.
Yeah. Okay, so we're going to move up in scale next to things that we can see with our own eyes. We're talking about human-made satellites and collisions in satellites around Earth. I did a whole space junk episode. It was episode 8, so like a long time ago. But I think if you want to learn more about this, go listen to that. But we launch 100 rockets or satellites or whatever into space every year. And that number is growing. It's only going to get bigger. Apparently, according to the Outer Space Institute, we've launched 10,000 satellites since Sputnik in 1957. That is 9,300 tons total.
Oh my gosh.
Yeah, that we've literally extracted 9,300 tons of worth of material from the Earth and sent it off of the Earth.
Wow.
There are still more than 4,000 satellites in operation that are orbiting around the Earth, and there are 128 million pieces of debris. About 900,000 of them are bigger than a cubic centimeter, and based on simulations, if something even a cubic centimeter were to impact the ISS or one of the other permanent stations or satellites, like it destroys it because they're moving at 58,000 miles per hour.
So man-made things are colliding all the time too.
They don't collide all the time, but they do collide sometimes. And as we continue to put stuff up there, they will collide more often.
Well, because you don't have control over the path, right? Oh.
Not once the satellite has been decommissioned. Right, because we've launched 10,000 satellites, but less than half of them are still working. The other half, some of them are still floating up there. Some of them, when they're done with their mission, you can re-enter them into the atmosphere. And if they're small enough, they'll just burn up in the atmosphere. But there's still a lot up there. And the first time there was an accidental collision was in 2009, which I think is pretty impressive.
Yeah.
That it took that long.
Many years.
Mm-hmm. It was between a privately owned communications satellite from the U.S. and a Russian military satellite.
Well, the U.S. and Russia, they are obsessed with each other. So
the space race goes back far.
It does. It goes deep.
But since then, there have only been a handful of collisions of sizable objects. But there is this hypothesis that in the future, as we continue to put more junk in space, that eventually it'll be so full that there will be a cascade of collisions. In 1978, there was a paper by an astronomer who coined this phenomenon and called it the Kessler syndrome. His name was Kessler. Maybe other people called it the Kessler syndrome. I don't know. But now there is this kind of nightmare scenario of what would happen in the future after all those collisions are possible.
And when all the collisions are happening, like what's happening? Is this debris falling back? Is it creating like stuff in the atmosphere that's harmful to us?
It's above the atmosphere, and they're usually moving fast enough that they're not going to fall back down. And if they do, the pieces are small enough that it probably won't fall to the ground. I think there have been situations where like full satellites have accidentally fallen unplanned to the ground, but that's rare. Mostly, it's just going to be like a debris field, like a junk field up in low orbit. Oh. And then we won't be able to put satellites up that we want to run.
Yep. So there would be a big loss of research.
Yeah,
and
exactly.
It would kind of be, I guess it would kind of look like WALL-E.
Yeah, yes.
Yeah.
It's the WALL-E future. That's the Kessler syndrome.
Oh.
I know. We don't want that. So we got to figure something out, and we can't just keep sending stuff up into space.
Yeah.
Like willy-nilly.
Are they trying to figure it out?
Yes. Yeah, they are trying to figure it out with law stuff. Space law is an active field, but they're also trying to figure out how to clean up the debris that's already there. I've seen some proposals that are like a giant net in space, like no lie, like actually just like a giant net in space.
That was my first idea. What about a net?
Yes. Look, sometimes the simplest answer is the best. But
a big butterfly net.
A big butterfly net or big lasers or something. But yeah, they're trying to solve it.
Wow.
Yeah.
Okay.
Mm-hmm. Human-made satellites. But then there are natural-made satellites and natural-made planets that form through collisions. This is how planets form. When a star forms from a big cloud of gas, not all of the material from the cloud makes it into the star. Also, the star, being born is hard, so the stars throw up material and then that gets out into the disk. But everything is spinning, so it forms this flat, we call it a protoplanetary disk around the young star. And as things are orbiting, they collide. So you get these tiny grains of dust that snowball into planets. Sometimes things collide with those planets, like other little rocks that have formed. And when they collide, they will either split up or they'll just knock a chunk off. And that's how we think our moon formed. We think billions of years ago, an object roughly the size of Mars hit the Earth. We call it Theia, hit the Earth, and whatever piece was knocked off formed at first, we think, a ring, probably a ring of material that then collided to form the moon.
Mm-hmm. So all of the planets are born from collisions.
Yes, pretty much. And first you get the giant planets made of gas and ice in the outer solar system because ice is really sticky and it's just more efficient for the ice grains to stick together out in the solar system. So you get the Jupiters, the Saturns, and the Neptunes, and the Uranuses, can't forget those, that form first. And then that happens in about 10 million years. And over the next 10, 20 million years, the inner planets will form. And by then, most of the gas has been gathered by the gravity of the giant planets. And also a lot of the gas close to the star has been evaporated away by its energy. So you get the small rocky chunks.
Okay. I'm just trying to keep up.
I'm sorry. I feel free to tell me to slow down or
No,
that doesn't
don't
make sense
ever
when I stop.
apologize. You're so smart. It's amazing. Yeah, and then the planets start. When do they start moving?
They're always moving.
They're always moving. Okay.
Yeah,
of course they are.
This is like a perpetual avalanche.
Okay.
Yeah.
So as they start forming, they're already spinning.
Yeah. They're all just rolling around the star, collecting material.
Even in destruction through their birth, they never stop moving. They're always moving. Okay.
Yeah, and we think based on simulations, we actually end up getting more material from the clouds of gas around us as the planets are forming. We used to think that the planets just formed from the material left over from that one star, but now we know that there is more supply coming in over time.
So even now, there is supply coming in?
Maybe not anymore, but at least for the first billion or so years of the solar system, whereas we used to think that it was just you get that one spurt of gas and that's it. Now we know that there's a program for new stars and their young planet children to like help them through, giving them more gas for the first like billion years.
Do you think the Earth will collide with anything ever?
It's a great question. Nothing that is big enough to completely destroy the Earth. We do know that planets in outer solar systems can migrate closer. We see many examples of what we call hot Jupiters. So they're giant gaseous planets, but they're so close to their stars that they orbit in like a day or a week or something. And they almost certainly couldn't have formed that close to the stars. So they must have moved in over time. And we have evidence that maybe Jupiter kind of moved in, but then moved back out long ago in our solar system. But our planet's orbits are very stable. So we can predict and we can run simulations that show really only like tiny asteroids or something will come and hit the Earth. And yes, they are tiny. They can still destroy like cities, but we don't have any like planet destroyers really.
Okay. But asteroids, like, do you know how far away they are? Do you know when is the point when you know that could potentially happen?
We should know fairly well in advance. We have the NASA center that is constantly monitoring near-Earth asteroids. So they have flagged all of the potential ones that might hit us. I don't know if you remember a few months ago where there was talk that an asteroid was supposed to hit us in a couple years.
I feel like I hear a story like that every few years.
Yeah, because every few years, this agency is like, oh, that one has a chance. And the chance has never risen above like 5%, really.
Oh.
Yeah, the chance is always really small because space is so big and these rocks are maybe like 30, 50 miles across, the biggest ones.
And the asteroid, it's just like traveling on its own though, right? Or it's not being pulled by us.
No. I mean, if it gets close enough, it will experience a small tug from our gravity, but they are definitely being dominated by the gravity of the sun. So they are orbiting the sun, and occasionally our orbits might intersect.
I see. Okay.
Yeah.
Fascinating.
Sometimes an asteroid is coming by and it's orbiting the sun, but it gets like pulled into our gravity just a little bit. And it doesn't hit us, but it does orbit us for a while. And that's how we get a temporary moon.
Oh, and we've had those?
We currently do. Yeah, we have, I think, 7. We call them quasi-moons.
And you can see them?
Not with your eyes. No, they are too small for that. But you can see them with telescopes. And they can last like a few months or a century or something.
And when they last, it's either they're going to be pulled into our orbit or they're going to be kicked out of it. That's what happens? Yeah, it's the gravity equations for the Earth and the sun's competing forces work out so that the quasi-moon will do like a few orbits around us, but it's technically still orbiting the sun. And over time, our orbits won't match up anymore. So we'll just like go our separate ways. Whoa, it's a situationship.
Yes, Maria. It is.
I'm like, they're flirting. They're flirting with the Earth and they're giving vibes like they want to be committed and then they're done.
Everyone comes into your life for a reason, a season, or a lifetime, right? These moons are for a season only.
Seasonal moons. Wow. I had no idea we had seasonal moons.
I actually helped Radiolab run a contest to figure out the name for one of our new quasi-moons, and we named it Cardia. There was a public vote. We like whittled it down to 7 names, and then there was a public vote, and the public chose Cardia, who's the Roman goddess of hinges and doorways.
Oh, that's so appropriate. Wow, so you got to be a part of naming a moon, a quasi-moon.
Yes, a very small part, but it was super exciting.
That's so special. I love that.
Yeah. And I love the naming conventions that we have for the moons, because all of the other planets have like strict rules for what the names of their moons are. And since we only have the one permanent moon, and its official name is just the moon.
Iconic.
Yeah. Capital M.
Beyonce. Zendaya. Lizzo.
Cher. Yeah.
The moon. Cher.
Exactly. It's in great company. And that meant that there weren't necessarily strict naming conventions for the other quasi-moons. But now we've kind of established that it should be either figures from folklore and mythology who are moon deities or figures who represent transitions and liminal spaces, because like the near Earth orbit is the transition zone between us and the rest of the universe.
That's so beautiful. I love that. Do you feel like being an astronomer, you are connected to spiritual deities like that? Like, is that a part of your, I don't know, your life?
I am a spiritual person. I know that there are things bigger than myself, and I usually, like, it combines with the science really well in my mind. Here on Earth, I'm kind of like a panpsychist and like everything has its own consciousness, so I'm going to respect that. But in terms of like conscious deities in that form, I don't know. Very open to it, but I don't know yet.
Open and curious.
Exactly.
Good way to be.
Yeah. What about you?
Yeah, I would say that I'm the same, open and curious. Like, I'm not writing anything off, and I'm open to learning. And and I think everything has its own energy, like you said. And it's about, I guess, staying curious and saying yes to whatever is happening.
Mm-hmm.
Not that you're like accepting everything that's happening, but you're accepting that the truth of like a situation or a reality.
Yeah, I mean, as a good scientist knows not to shut themselves off to the possibility of truth. Yeah, whatever form it may take.
Yeah, I love that.
Yay. Okay, the next scale I want to talk about is galaxy mergers.
Galaxy murders.
Mergers. Oh, well, sometimes yes, murders. Sometimes they are killing each other.
Oh my gosh, the merge and the murder.
It's true. So I wrote a book about the Milky Way, and I personified it, and it has all of these interactions with other galaxies. Some of them are romantic, and some of them are quite violent. And it really is so many galaxies out there in the universe just ripping each other apart and cannibalizing them for their gas and dust so they can make new stars.
Oh my gosh.
Mm-hmm. We think about 25% of all galaxies are actively undergoing some type of interaction right now.
They're interacting with each other.
Mm-hmm, with each other, yeah.
So is ours interacting?
Yes, lightly. So we are definitely interacting gravitationally with the small satellite galaxies around us, the large and small Magellanic Clouds, which you can see with your own eyes if you go to the southern hemisphere, close to it. They are like exchanging some gas with us, some material. In several billion years, they will be absorbed into the Milky Way.
Oh my gosh. Absorbed like in the way that we're going to gain new planets?
Yeah, the planets, stars, gas, all of it. And then with the new gas that we get from them, we are going to create our own new stars.
Oh my gosh. But some things will get destroyed, or no?
Very little, actually.
Oh.
Yes. So this is the first thing I learned that made me understand how big space is. Because we used to think that the Milky Way and Andromeda would have this inevitable collision. Now it seems the chances of that happening are more like 50%. But even if that were to happen, both of these galaxies, which each have more than 100 billion stars in them, they would collide, and maybe a handful of stars would touch.
Wow. Mm-hmm. So there is a lot of space.
Yes, the space between stars is thousands of times bigger than the size of the stars themselves. I pulled a quote from a paper. It said, "The chances of two stars colliding in a typical galaxy merger are less likely than you tossing a coin 27 times and them all coming down heads."
Oh, wow. Okay.
It's very unlikely. It really just means that it's a time of creation. Actually, because the gas swirls and there will be new stars, and gas will fall onto black holes, and it will like start these interesting feedback processes. We know that the dynamics, the like orbits of stars will change. Usually we see two spiral galaxies. Most of the galaxies that we see are spiral shaped. about 20% of the galaxies, like 15% of the galaxies we see are what we call ellipticals. But we know that when spirals combine, they lose their spiral shape and become elliptical galaxies because they're just so chaotic in that merger that the neat, organized orbits are destabilized.
Oh, so a spiral is organized.
Yes, very organized.
And then elliptical is chaotic.
Chaos.
Okay.
Mm-hmm.
Okay,
Yeah.
so does that mean that the other galaxies that you see that are elliptical, does that mean they've been combined?
It does.
Oh.
Yes. It really means that there has been a major merger, because there are major mergers where the two galaxies are roughly equal in size, and then there are minor mergers. The Milky Way has had dozens of minor mergers throughout its life, but they don't really change the shape because the other galaxy basically doesn't put up much of a fight. Like, it doesn't have as much gravitational influence, so the Milky Way can still maintain its shape. But my favorite thing about elliptical galaxies is that they literally maintain their shape from the chaos, from the stars moving in like all different directions at different speeds.
They're strong. They have a strong nucleus. No, that's unrelated. That is so amazing. Oh my gosh. This is all so romantic.
I agree. Yeah. Like, the galaxies are just interacting out there and they form little communities. We see galaxy clusters where there are, like groups of 50, 100 galaxies all getting together. And you can see social dynamics too. We call the most massive, like gravitationally dominant galaxy in a cluster the central cluster galaxy. Like, it is the it girl. Like, they're popular girl galaxies.
That makes so much sense that the universe is just a macrocosm of everything that's happening here.
Yeah, of course it is. Yeah, everything is fractal. You're going to find the same patterns all the way down.
Wow.
Yeah.
I love that.
Yeah. So those were collisions in space at different scales. Thoughts, reactions. How are you feeling after the last hour?
Wow. Yeah. When you think about all the things happening up there, and then it just, I feel like I have no words. It just feels like all that energy is all happening inside of us and around us. And it just feels like it's kind of comforting, honestly. It's kind of like, oh, yeah, like I'm just a ball of matter and energy too. And I'm just trying to like get through. I'm just trying to keep my moon and stay in my lane.
Yes.
But there's going to be other galaxies and stars and black holes around doing their business. And it's about, I guess, keeping that strong nucleus.
Always keeping that strong nucleus and keeping that perspective.
The perspective, yes, very important.
One thing that I have gained from thinking about collisions in space is the idea that very few of these collisions are purely destructive. Out of so many of them, you get something new and beautiful and unexpected that you wouldn't have gotten any other way. And I try to apply that to my own life sometimes. Like, collisions can feel uncomfortable in the moment, or like conflict, and usually out of that is going to be something beautiful that you couldn't have gotten without the collision. So I try to remember that.
That's such a perfect message. Yeah, I remember you saying it's a time of creation. It's a time for you to create new things, for new things to come. And that's, and you have to be open to it, right? Like you said, you have to be open and curious instead of maybe just meeting the collision with resistance or violence or, being unmovable. Love that.
Oh, absolutely. I think that's a good note to kind of wrap up on. But Maria, I would love for you to brag about yourself for a minute. Tell us what you're working on and where people can find you online if you would like.
Yes. Thank you for the opportunity. I'm a stand-up comedian. I'm always doing shows around the city. I host a monthly show at the Stand Comedy Club in Union Square. And then I'm also around at different shows. And I'm working on my longer solo piece, which I just did at Joe's Pub. And hopefully going to have another little run soon and then film that special. So yeah, follow me on social media and you can stay up to date on shows and stuff, and hopefully it can make you laugh.
Great. What handles, what links should people search up?
So all my social media is just my name. So it's just at Moiya DeCotis, and I'm sure you will have it written.
Yes, that will be in the show notes for sure. So
Perfect.
Listeners, go check it out. We met at a lecture on TAP. Which was it the one about the Milky Way?
Yes. I remembered your part of your PowerPoint with the shapes of the different galaxies.
Yay. Yeah, I love talking about ellipticals versus spirals. Mm-hmm.
Yeah, I remembered that one very vividly.
Awesome. Okay, well, listeners, no matter how you go into a collision, remember that you are space. Bye. Pale Blue Pod is hosted by me, Dr. Moiya McTier, a.k.a. the universe's bestie. I created the show with original co-host Corinne Caputo, a comedienne extraordinaire, and help from the Multitude Productions team. Our theme music is by Evan Johnston, and our cover art is by Shay McMullen, and our audio editing is handled by the incomparable Misha Stanton. I am Go Astro Mo everywhere online, and you can stay in touch with the show and the universe by following Pale Blue Pod on Instagram or checking out our website, palebluepod.com. We are a member of Multitude, an independent podcast collective and production studio. So if you like Pale Blue Pod, you will love the other shows that live at multitude.productions. And if you want a shout out on the show and research notes for every episode, you can join our community over at patreon.com/palebluepod for just about $1 per episode. Thank you so much for listening to Pale Blue Pod. I'll be back next week. Bye.